Hello, I'm Illah Nourbakhsh, and I'm from the Robotics Institute at Carnegie Mellon. Now, the department that I'm part of is robotics, which is a whole lot of technology work, but I run something called the CREATE Lab, which stands for Community Robotics, Education, and Technology Empowerment. And that's a little unusual, because what we're all about is empowering people with technology to change their own world. And in fact, this project, ChargeCar, is a very important empowerment project. So I have to start by telling you how I got empowered about electric cars and how that's led to where we are now. So these are the two cars that I have built in my life, or driven in my life, I should say. The car on the left is the Stanford Sun Surfer that I was involved in building and then racing across the country. And the car on the right is a Toyota RAV4 EV that I still drive daily. And this thing was sold to me in the year 2000. And it has continued to work without ever going in for service anywhere. So that's 12 years of perfect running. The only thing that I've done is change its tires. There's two important lessons I learned about electric cars, about the ability that they have to engender community engagement just with these two cars. With the one on the left, I understood and appreciated how elegantly simple electric cars can be because they have so few moving parts, less than 1/100th as many moving parts as a gasoline engine car. Well, the one on the right taught me how engaged and excited the community at large is about the idea of electric car transportation. I drive this car every day in all manner of parts of Pittsburgh where we do outreach programs from the CREATE Lab. Everybody knocks on the window and asks questions and wonders, how many miles does it go? Can I get one, please? What kind of batteries does it have? Questions like these. And so in fact, what we determined with this car, which again is elegantly simple, it doesn't break down at all, it works in the winter, works in the summer, no problem, is that the range it has, which is 120 miles, and the way that we get to interact with people on the road leaves them desperate for access to possibilities that don't require gasoline, that don't require constant service and maintenance, that don't have the kind of street noise that leads to loud streets and crowded streets and polluted streets on our city's neighborhoods. So that's where this project began. And now the beauty of having a robotics lab is that you can have your students hack commercial vehicles. So in fact, we hacked that electric car, got into its computer system, and started to note what kind of measurements of power there are going in and out from the batteries to the motors and back. And that was interesting, because we weren't expecting something that has so much noise up and down. As you can see, there's a whole lot of discharge events below the flat horizon line, and there's a great deal of charging events. For instance, when you're stopping at a red light or going down a hill. That's all the peaks that are going up above the horizon. What was interesting about that is the idea that an electric car's battery is doing something that batteries aren't really designed for very much, which is it's massively switching rapidly between charging and discharging all the time as you drive it around a city. As you slow down in front of somebody, speed up again, stop at a red light, speed up at a green light. You're constantly in the world of switching the direction of current transfer on the battery on it. When we measure that and start to do some statistics, we saw some really fascinating things. For instance, even though my entire commute ends up using net 5 kilowatt hours of power to get to CMU from my home in Squirrel Hill, in fact, 27% of the time, I'm charging the battery rather than discharging it, which is really interesting. It's a recyclable, rechargeable battery, but the battery's life ends up depending a great deal on the total amount of work it's done in its lifetime, and that depends on how much it's charged and discharged. So what's interesting about this number is it leads us to think about hypothesizing ways to use batteries in electric cars more intelligently, using control and optimization from computer science, so that you don't end up wasting time charging it, but instead find other ways to store the energy and return it to the car without having to use up your battery life. Now, the ChargeCar project came out of this realization that in fact computer science and computational thinking has a role in how we build the car of the future. So we work on all areas of model design, how do we create electric car models, control, how we actively manage the energy in an electric car, everywhere from designing and controlling the thermodynamics of the battery, how we cool and heat it, to predicting how the human drives and using our predictions of what's about to happen next to properly control the battery's inputs and outputs. And we even have at the very bottom community engagement, the idea of learning how to talk to local communities and have them envision together with us engineers how the car of the future can be part of their network. Now, one interesting engagement angle is to give people a GPS unit and teach them how to use it to record their commute. So we created a way for people to take any GPS, record their commute, and then upload it to a website we created called ChargeCar. And this is active, and you can go there now. What's exciting about that, and by the way, more than 100,000 miles worth of people have noticed this website and used it, is that when you upload your data to ChargeCar, it immediately computes for you, if you were in an electric car, how big would your battery would have had to be for your commute? And how much work would that battery have done? And how much gasoline money would you have saved if you had had an electric car on your commute? So this website allows you to immediately visualize yourself with an electric car on your commute. So we take data that matters to you and allow you in a more intimate way to imagine your future with a different kind of energy vehicle. Some of the interesting things that we've noticed, for instance, this is a plot showing the total amount of energy required for various commutes of all these 100,000 miles that have been uploaded to our website. But you'll notice that a whole lot of the miles, more than 50% of all the commutes in our database, need 1.5 kilowatt hours of battery power total. That's less than 2 12-volt batteries. So when we talk about $100,000 cars or $60,000 cars that have 30 or 60 kilowatt hours of power, like a Tesla Model S, that's well and good, and that's a fantastic machine. But if you think about what people actually need, people for whom the price of gas actually matters because they're low-income or middle-income folks, for them, a car with the equivalent of 2 lead-acid batteries of energy will get them to work, it'll be simpler to operate, and far cheaper in terms of cost of maintenance over the long run. And that, to us, is very exciting. Now, where do we take this? Where we take this, excuse me for that, is we take it towards the idea of taking a car, like a Honda Civic, and coming up with a way to convert a used car into an electric car. And so where I leave you with is the creation of our electric garage, a facility where we actually train mechanics to take gasoline cars and take all the gasoline elements out of the car, just like this, and turn them into an electric car. Put in an electric motor, keep even the clutch plate so that the car's manual transmission still works, and end up with a car that's a completely electric charge car. This car goes more than 45 miles and can be done as a conversion by an independent auto technician in an independent garage in about 2.5 days. Now that's exciting because from a recycling and community engagement point of view, you're creating local labor and local jobs with local mechanics. You're using local materials, which is a used car, rather than spending all the carbon footprint making a new car. And you're creating something that as a niche product may be able to fulfill certain people's needs as a commuting vehicle. So we've created an electric garage right here at Carnegie Mellon University across the street off of Forbes Avenue. And that electric garage houses events where we have people like Jay Apt come and give speeches about the electric industry. We have events where, for instance, West Virginia, Wheeling Jesuit University will come and show off their electric vehicles, including their formula racers. And we screen movies there in the evening. For instance, we showed Who Killed the Electric Car and a number of other movies like Gaslands right there, inviting the community of Pittsburgh to come and enjoy talking about cars, about transportation ecologies, and about how computational thinking in computer science can lead to a type of car that could truly solve real problems here on Earth. With that, I end, but I want to show you both our corporate collaborators, such as Bosch, which is funding a great deal of our work on optimization, Bombardier, which funded our work into electric people movers, Intel Corporation, which has given us computer systems that are in every one of the electric conversions we do, and Zipcar, which helps our ecology by hosting 2 Zipcars at the electric garage. So now any person driving an electric car can park their electric car at the electric garage, charge it with our 8 Generation 2 chargers that we have set up there, thanks to Eaton Corporation. They can take the bus from there, or they can jump in a Zipcar and go off from there. So now we've created a center, a nerve center in Pittsburgh for not just electric cars, but for intelligent alternatives in transportation. Finally, the Heinz Foundation has funded us to actually do the community engagement that allows us to communicate with the public and expose them to the idea of this kind of research gone to the real world. Thank you.